Anyway, welcome. Hope things are going well for you. Here we are having a Tuesday on a Thursday because the Tuesday was a testing day, but that's all right. We can manage that. It's wonderful to see all your lovely faces this morning. Let me put this up and see how much we get covered here in just a short amount of time. Looking at what we're doing this week. All right, our grade screen.
Like that works
It shows us. Okay, last week we had matrix dimensions, matrix elements, and representing linear systems. I'll tell you with this matrix stuff, it's a little bit more confusing, so be sure and check the grade screen often to figure out what am I doing this week. Look over here in the right-hand column. This is the due dates. And we can see this week there are 3 things that are due this Sunday. 3 things. Though these are 3. You want to do the matrix row operations, add, subtract matrices, and matrix equations, addition and subtraction. So those are the 3 assignments this week. So let's go back and take a look. Matrix row operation. We did that last week. So everything is in this adding and subtracting matrices. Everything inside here, I think. Let's look at that again. Hold on.
Your assignment today is going to be.
Oh, we haven't done matrix row operations. Okay, matrix row operations and adding, subtracting matrices. Okay.
There we go. It froze on me for a
Let's
second.
get back.
So your assignments this week are puzzles on these animals that we're talking about.
So we need to
No
do
project connected to this week.
matrix row
And
operations
that makes you guys really sad.
and the adding, subtracting matrices
You
folders.
will have to
Those
break
2
out
folders.
Anna, does that make you
Just
sad?
get
No
married.
project? Just
Get that folder and that folder all done. So this is a video.
So we are talking this week.
No, this is a list. This is a list. We'll look at that real quick. Then there's the assignment. And then you've got a video and a lesson down here. So that'll be good. But let's take a look at the matrix row operations, because this is the thing that can be a little confusing.
All right. So we're talking this week
Close
about
the side tab. All right, there are things we can do with matrices,
compare and contrast.
different
And they're very
operations we can do,
different.
and this kind of
These
summarizes
were
the
fancy
3
animals,
the 3 elementary operations that
very
we're looking
different.
at doing.
And then
So the
analyze
first
how
one is right here, and it's switching any 2 rows.
adaptations have made
Okay.
them.
Like we can take rows 1 and 2 and
Okay,
just
and
trade
maybe
places.
again, we'll find a new favorite animal.
Or if we had 4 rows, we could pick any 2 of them and trade places. Okay, that's one of the operations we do with the matrix. Exchange row 1 and 2. So you see that starts with 2, 5, 3, 3, 4, 6.
So
And what they did is they just swapped places with it. Now it's 3, 4, 6, 2, 5, 3. So that's one of the basic things we can do. The other thing we can do, another thing, is multiply a row by a non-zero constant. Notice row 1 is being multiplied times 3. Every element in row 1. So instead of 2, 5, 3, it becomes 3 times 2, 3 times 5, and 3 times 3. We're just multiplying every number by 3. So it becomes 6, 15, and 9. Another thing we could do is we can add a row to another row. So row 1 did not change. See, it's still 2, 5, 3. But the second row, what we did is we took the first row and the second row and we added them together.
Are you here?
3 plus 2. We took 5 plus 4. Oh, that's a slot, circle there. 3 and 6.
Oh,
Add them together. So it becomes 2, 5, 3 and 5, 9, 9. Okay. Does that really work?
All right.
Sure. Let's look at them individually. Switch any 2 rows. And this is what you might see as the operation to do. See, it's got that double arrow, which means take row 1 and row 2 and trade places. So row 1 and row 2 means to interchange them both. So 483 moves down to the second row. 2, 4, and 5 moves up here to the top row.
Yeah, octopus are ridiculous.
Sometimes you may see it like this. They'll just put it in between the 2 matrices to explain what happened. Let's say it started out like this and it ended up like this. And this is what we did. We took those 2 rows and traded places. Notice the third row is just the third row. Nothing happened because it did not say to do anything. If it doesn't mention the third row just stays the same.
Snails do not like salt. Yeah.
So here's our problem here. Let's see.
Sophia said snails do not like salt. Maybe that's like.
Put this in the chat. I'll open up the chat.
Because it actually
Perform this row operation. Row 2 and row 3.
Yeah, if you ever like trying to
are
get rid of
switched.
snails, or the other one you can put in your garden.
So what's that mean for the first row? Nothing. It stays the same. 7, 2, and 9. That's the first row.
What else do we know?
Second row.
Even for octopus knowledge.
What's the second row? Put that in the chat.
Yes, Anna said octopi have 3 hearts, and octopi is the plural. If you Google it, so let's do this. Google it. Find fun facts about snails or octopus. Put it in there. Teach somebody something new today. Give you a minute.
All right. Putting the whole thing in there. That's good. Yeah, the second row is what the third row used to be. So then the third row gets to be what the second row. We just take the second row and the third row and we swap them back and forth. Perfect. Yeah, Summer was doing the whole thing for us. Check. Perfect. Let's look at multiplying a row by a non-zero constant. This is how you would see that in the problem. 3 times row 2 becomes the new row 2. So replace row 2 with 3 times row 2. So what they do is they say, here's the original. Here's what the original row 2 was. We're going to multiply 3 times every element, and it becomes 690. That's 3 times row 2 replaces the second row. And again, they may put it in between there to explain why this matrix changed and became this matrix. So let's try that. 2 times row 1 is the new row 1. So that means, what are we putting in row 1? Put that in the chat. All right. Great. Yes, just simple multiply by 2. Man, how great is that? You're in a high school class and you're being asked kind of multiply times 2. Feels like you're back in 3rd grade, doesn't it? 4, 12, 10, 2. And the second row is just the second row. We didn't say to do anything with the second row, so it stays the same. Stays the same. Perfect.
So, our differences here.
This is where it gets a little interesting. We're going to add one row to another. Row 1 plus row 2 becomes the new row 2. So if we have this original matrix here, the 2, 3, 4, 0, 8, 1, we take the 2 and the 0 and add them together. And that's the new second row. Now notice the first row, nothing happens. Even though we're adding it to the second row, we're only replacing the second row. So we don't care about changing anything. 3 and 8. 4 and 1.
It looks strange.
So 2, 3, 4, 0, 8, 1 becomes 2, 3, 4, 2, 11, 5 when we add them together. So here's our practice problem for that.
So it's not like a hermit crab.
Row 1 plus row 3 is the new row 3. So that means row 1 and row 2 are still row 1 and row 2. So we just, I like typing those in first before I try to figure anything out, because I know they're not changing. Only row 3 is changing.
And then the radical.
1, 16. So what is row 3 then?
So there's 3 classes, and you guys will have access to these slides shortly. There's 3 classes, 3 groups within the mollusks. Okay. Mollusk literally means stomach foot.
So let's take row 1 and row 3. So we're going to take negative 1 and we're going to take 7. And we're going to add them together.
So torsion, if you think of it like
it's negative 1 plus 7.
When they're developing, their visceral mass will twist.
Then we have to take the 6 and the 2 and add them together. What's 6 plus 2?
With snails,
is
go to the bathroom, they're
negative 2 and 1 and add them together.
It is a, there we go.
Good job,
Some
guys.
of you, I saw your face, you were listening.
Oh, I see a challenge problem.
But then we have some that are actually predators. They're going to hunt animals down.
Row 1 plus 2 times row 3 is now row 1.
Let's look at our first group. So it was Sophia who brought up
row 1. So I can go ahead and put row 2 in.
They're in the same group. So they're in what's called
and row 3. Because it didn't say to do anything with row 2 and row 3. So I went in and put those in exactly like they were. So what is the new row 1 going to be? Oh, challenge problem. I love it. A little tricky.
Okay.
Not really tricky. We just got to follow the directions.
My favorite is the ocean.
There's the directions.
So here is a diagram of that torsion.
So the first
These are
element
slides that you're going to need
in
for your
row
breakout
1 will be, well,
so when it's developing, when the snail is
row
developing,
1 is
their
negative
body
5.
literally folds in half.
2 times row 3, that's an 8.
And then their radula, so this is
So
where
2
twins
times
say
8
that
is
there's thousands of
16.
teeth. It appears
16
as
plus
such,
negative 5.
Okay. But on their radula, it has all these little like
That number's
sharp
11. It's 2 times this number and then add it to this number.
They're not going to cause you to believe, but
So 2 times 8 is still
and so when they're
16.
moving along,
And
they're
we're
actually
adding it
scraping
to 7.
algae or plant material off of objects.
16 plus 7.
And then some like
Negative
these,
6
coat snails,
times 2 is negative 12.
they actually have
And then we
a
add it
venomous
to row
harpoon
1.
They will use to like shoot out
Negative 9.
that they can eat those instead.
Perfect.
All right, so our next group.
So basically the
The
reason we would do any of this
scallops,
is,
like
let's say we
even
have this systems of equations to solve, right? We have these 2 equations right here. And sometimes when we solve them, we could rearrange them. We could say, instead of writing them like this, I'm going to write them like this, which means I'm just trading places. That's why it's legal to do the same thing with the matrix. We could just swap rows 1 and row 2 because we rewrote our systems of equation. It's still the same. It's still equivalent. It's still the same set of equations. It doesn't matter which one's first. So that's why we're allowed to do that. How about this? Remember, sometimes when we solve this, if we solve it by elimination, sometimes it's like, okay, I want to get rid of the x. So I'm going to multiply this by negative 2. So I'll have a negative 2x and a positive 2x. See, and when I add them together, it'll go away.
They're the outliers of the
Solving by elimination. So when you multiply everything here by negative 2, that changes this equation to this. That's why we're allowed to do that with a matrix. You just take the entire row and multiply it by negative 2. Because that's the same thing we would do solving a system equation by elimination. We would try to get those equal to each other, one with a positive, one with a negative, so we can add them together. So that takes us to adding one row to another. So when we did that, when we changed this to a negative 2 and a positive 2, the next thing we did was we add these together. And that gets rid of the x, right? So if we add those together, we got rid of the x in the second row. So it's now negative y equals negative 4.
And then water enters through what's
and then we would work later with this other one to try to get an x equals. Because right now we've got negative 2x minus 6y equals negative 10. But this is solved for y right there.
Where they are harvested.
So that's why we can add 2 together and replace a row. Because we do that with the systems equation.
Are cephalopods.
All right, I like this problem right here. All right, this is the last problem we're going to do because we're going to run out of time. And this is the end of this lesson. Right? Here's our original matrix right here.
Okay.
Somehow, this matrix turned into this matrix. Somehow.
Right.
It went from that to that.
In some of them, the shell.
Here's the 4 things. We could have done this, this, or this. I'm going to say 1, 2, 3, and 4 for your chat. For the chat. Did we do this? Did we do this? Did we do the first thing? Did we do the second thing, the third thing, or the fourth thing? How did this matrix turn into this matrix?
Open them, they give them mazes to work through. They can
2, 2, 10. 2, 2. So the first row is the same. Right, that didn't change.
That will actually allow them to.
The second row used to be negative 2, negative 3, and a positive 3. Now it's 0, negative 1, and 13. How did we do that? Did we subtract the second row from the first row and make that the new first row?
So now we're looking at.
Did we take 1/2 of the first row and make that the new first row? None of these could be because we didn't change the first row. The first row is the same. So it has to be one of these two.
Then we already talked their tentacles and their
So
arms,
did we
their
add the two
extension.
rows together and make that
And
the new
instead
second
of
row?
that
Or did we
fractal
take
like the others,
negative
they
one
actually have
times the second
three
row? Make it the second row.
in the middle. They usually compare to a
Alexander's on this. The only way
Uh,
this could turn into
Invertebrate
this
cephalopods have the largest brain, so if we're going like
is we
brain,
must have
function,
added, I'll
they
move
have
that up.
their amazing categories.
We must have added row one and
So
row
here's
two
what
and
you're
make
gonna
it
do
row two.
today.
2 plus negative 2.
Let me go over
We
the
did
task.
2 plus
You're
negative
going to
2.
break out rooms.
Add those two
Dots
together.
on each other. I have 8.
That would be
We'll
0.
do
That would be a 0.
3, 3, and 2. Okay.
If we
So you're gonna
add
get
2 and negative
files.
3 together, that would be negative 1. And 10
We will
plus
have
3 is
them slide
13.
here shortly.
So that's perfect.
So when you get to your
So
room,
now,
choose one.
how did this one
So
turn
you get
into
a
this one?
description of the
What
answer.
happened there?
Okay.
It's either this, this, or this. Either the first thing and the second thing or the third.
Talk to each other to make sure you're comparing data.
The second row now has stayed the same.
On your
We
document,
changed the first row from 2
you were going
to
to tell me what
10
class it's in,
to 115.
what evidence you have to put it in that class.
Which one
then
of these
a diagram.
operations did that?
Okay, so your slides will start here. Okay. In case file 1.
Well, this one talks about changing the second row,
Okay,
so it can't be that.
Okay.
We
What
must have
is
just
on your
multiplied it by half.
tab?
That's that right there. Let's move that up. Yeah, 1/2 of row 1
Okay.
become row 1.
So I'm gonna
That's
put
what
you
we
in
did
the
to get
breakout
this.
rooms.
So how do we
after
go
you're
from
done
here
with
to
that,
here now?
Mark it as done, come back to the main room so you have a place for
115.
And
115.
then
Okay,
when
first
you're done
row's the
with
same.
that, you have
First row's the same.
3 different
0,
and
negative
that
1,
because what we
13.
needed today,
0, positive 1, negative 13.
heavy project thing.
Oh, we did this right here. We multiplied the second row by negative 1. Which now by process of elimination, we must have subtracted the second row from the first row to get the first row. 1 minus 0 is 0. 1 minus 1
Okay, so that
is
is in your
0. Yeah,
classroom.
right there. I'm sorry. 1 minus 0 is 1. 1 minus 1 is 0. 5 minus a negative 13 is now 18.
So you guys check, is that in your?
I want you to
classroom?
notice
It
something.
comes up if it is. It should say
What did we end up with?
case file analysis.
X equals 18.
Yeah.
There's no
Okay,
Y.
Okay, so in your breakout room.
Y
you
equals
can
negative
ask
13. There's no X.
introduce yourself.
If you convert this
Okay.
back to an equation, there's no
When
X.
you're done in there,
there's
make
no
sure you
Y.
talk to each other.
This is the solution
Well, for 13.
to that systems of equation.
Then you
X
come
equals
back.
18, Y equals negative
You're
13.
working on your 3 different.
That is the
You
solution.
should be able to get all your work done
Starting with the very original matrix up here, the original equation.
as long as you were focused, okay? And then we're looking at any
All right.
work. If you
That is the lesson.
you were logging in,
Matrix row operations. This will have your assignment, the first assignment.
Okay?
Be sure and go through each of
All right,
these.
so let me set those up. Again, any questions?
You know,
before I shoot?
ready to practice. Fill in the answers, and at the end, screenshot it. Screenshot your score where it shows the summary, and then scroll down on the same page and put your summary right here. Paste it. Here's what I scored. I got 4 out of 4, Mr. Brock. All right. Don't forget to submit it when you're done. The other thing you have, that's this first folder. Here's a video. Here's a lesson, and you have these 2 assignments this week. So that's what you have. You have this folder and this folder, 3 things to turn in this week. All right. I would hang around longer, but I got to get to my doctor's appointment. Any questions on that? Watch the video, look at the other lesson, and then do the other 2 things as well. And that's all you have this week. Those are the 3 matrix assignments. If you still haven't got last week's done, we can get that done as well. But that's what we have. I got to go to a doctor's appointment, unfortunately. All right. If there's no questions, I'll let you guys go. You can email me. I'll check it. I won't be gone all day. They're real 5 minutes away, so I'll be back here in an hour or so. I'll check emails if there's anything you need, and I'll be happy to get back. But sorry to cut it short, guys. Have a
Sophia, does
good
that
week.
show up for you?